Jai Hind to all. Today we start a new chapter, that is integration. Actually, integration in the 12th class, integration consists of 3 steps, 3 sections. That is integration. First is indefinite integral. Integration contains indefinite integral. Indefinite integral. Second, definite integral. Definite integral. Definite integral. And third section, applications of integration. Applications of integration. Okay. In the second 12th class, our integration portion containing 3 sections. First is indefinite integral. Second is definite. And third is application integration. Now our first section, indefinite integral. Actually, integration is the inverse process of differentiation. Our definition said that integration is the inverse process of differentiation, just opposite. Inverse process of differentiation. You know, suppose you take derivative of sin x. Derivative of sin x. You know, derivative of sin x is cos x. Okay. Definition says that integration is the inverse process of differentiation. And then integral symbol is this. Integral of cos x with respect to x എന്ന് represent ചെയ്യാൻ we multiply dx. Here with respect to x multiply d by dx of sin x. ഇവിടെ integration വരുമ്പോൾ integrating with respect to x എന്ന് represent ചെയ്യാൻ cos x into dx, we get answer sin x. It's an inverse function. Integration is the inverse process of differentiation. Therefore, derivative of sin x we get answer cos x, and therefore integral of cos x we get answer sin x. Okay. Now, derivative of sin x plus 2. Sin x plus 2. Answer is cos x. Derivative of sin x minus 3 is again we get cos x, because derivative of minus 3 is 0. Derivative of sin x plus root 2 is again we get answer same answer cos x. But using definition integral of cos x we get answer only sin x. കാരണം നിങ്ങൾ പഠിച്ചിട്ടുള്ളത് integral of cos x sin x. അവിടെ നമ്മൾ ഡെറിവേറ്റീവ് ഓഫ് ദിസ് ഫംഗ്ഷൻ നമുക്ക് എപ്പോഴും തരില്ലല്ലോ. അവിടെ ഓൺലി ക്വസ്റ്റ്യൻ ഇത്രയേ ഉണ്ടാവുള്ളൂ, integral of cos x. We get answer only sin x. Here also integral of cos x. We get answer sin x. Again ഇവിടെയും നമുക്ക് എന്ത് ചെയ്യാൻ കിട്ടുക, integral of cos x into dx, answer we get answer sin x. അപ്പോൾ ഇവിടെ നമുക്ക് ശരിക്കും sin x ആൻസർ കിട്ടേണ്ടത് sin x plus 2 ആയിരുന്നു. ഈ ഫംഗ്ഷൻ പ്രകാരം ഇൻവേഴ്സ് പ്രോസസ് പ്രകാരം റിവേഴ്സ് ഓർഡർ പ്രകാരം നമുക്ക് എന്ത് കിട്ടണം, ഈ ഫംഗ്ഷൻ ഇൻ്റഗ്രൽ വാല്യൂ തിരിച്ച് ഈ ഫംഗ്ഷൻ കിട്ടണം. ദാറ്റ് ഈസ് sin x plus 2 കിട്ടേണ്ടത്. ഇൻ്റഗ്രൽ ഓഫ് കോസ് ഇവിടെ എന്ത് കിട്ടണമായിരുന്നു, sin x minus 3 കിട്ടുക. ഇവിടെ ഇൻ്റഗ്രൽ ഓഫ് കോസ് നമുക്ക് ഇവിടെ എന്ത് കിട്ടണമായിരുന്നു, sin x plus root 2 കിട്ടുമായിരുന്നു. പക്ഷേ ആക്ച്വലി നമുക്ക് ഈ ഒരു ഫംഗ്ഷൻ എപ്പോഴും തരണമെന്നില്ല. ഡെറിവേറ്റീവ് ദിസ് ഫംഗ്ഷൻ ആണ് ഇയാൾ, അതുകൊണ്ട് ഇയാളുടെ ഇൻ്റഗ്രൽ വാല്യൂ ദിസ് ഫംഗ്ഷൻ നമുക്ക് കണ്ടെത്താൻ കഴിയില്ല. ഓൺലി ക്വസ്റ്റ്യൻ ഇത്രയേ ഉണ്ടാവുള്ളൂ, ഇൻ്റഗ്രൽ ഓഫ് കോസ് x മാത്രമേ ഉണ്ടാവുള്ളൂ. ഇവിടെ പ്രോബ്ലം ഇല്ല, കാരണം ഇൻ്റഗ്രൽ ഓഫ് കോസ് x വി ഗെറ്റ് ആൻസർ, ദാറ്റ് ഫസ്റ്റ് ടേം sin x നെ കിട്ടി. സോ ഈ ഒരു കോൺസ്റ്റൻറ്റിൻ്റെ ഇവിടെ റെപ്രസെൻറ്റേഷന് വേണ്ടി നമ്മൾ എല്ലാ ഇൻ്റഗ്രൽ വാല്യൂയിലും ഒരു പ്ലസ് സി കൊടുത്ത് പോകും. പ്ലസ് സി പ്ലസ് സി പ്ലസ് സി. ദിസ് സി ഈസ് കോൾഡ് കോൺസ്റ്റൻറ്റ് ഓഫ് ഇൻ്റഗ്രേഷൻ. കോൺസ്റ്റൻറ്റ് ഓഫ് ഇൻ്റഗ്രേഷൻ. ഇൻ ദിസ് കേസ് സി വന്നിട്ട് 0. ഇൻ ദിസ് കേസ് സി ഈക്വൽ ടു 2. ഇൻ ദിസ് കേസ് സി ഈക്വൽ ടു -3. ഇൻ ദിസ് കേസ് സി ഈസ് ഈക്വൽ ടു √2. That means integral of cos x into dx, integral of cos x into dx is equal to sin x plus c and the final answer. Integral of cos x into dx is equal to sin x plus c, where c is called constant of integration. c ക്ക് different values കൊടുക്കുന്നത് കൊണ്ട് തന്നെ ഈ ഇൻ്റഗ്രലിന് ഒരു ഡെഫിനിറ്റ് വാല്യൂ ഉണ്ടെന്ന് നമുക്ക് പറയാൻ കഴിയില്ല. They makes indefinite values. കാരണം c can take definite values, different values. So this function take the integral values makes not a definite value, contain indefinite values. കാരണം c ക്ക് വാല്യൂസ് മാറുന്നതനുസരിച്ച് ഇൻ്റഗ്രൽ വാല്യൂ മാറിക്കൊണ്ടേയിരിക്കും. അതുകൊണ്ട് തന്നെ നമുക്കിതിനെ ഇത്തരം ഇൻ്റഗ്രലിനെ നമ്മൾ പറയുന്ന പേരാണ് ഇൻഡെഫിനിറ്റ് ഇൻ്റഗ്രൽസ് എന്ന് പറയുന്നത്. ഇൻ്റഗ്രൽ ഓഫ് കോസ് എക്സ് ഇൻറ്റു ഡി എക്സ് ഈക്വൽ ടു സൈൻ എക്സ് പ്ലസ് സി, ദാറ്റ് ഈസ് കോൾഡ് ഇൻഡെഫിനിറ്റ് ഇൻ്റഗ്രൽ. ഓക്കെ. നൗ യു ഡിഫൈൻ ദ definition. Suppose if capital F of x is a function, if capital F of x is a function, then d by dx of capital F of x equal to, suppose we get a function small f of x. Derivative of capital F of x equal to, we get a small f of x. Then integral of small f of x into dx. Integral of small f of x into dx is equal to, we get that capital F of x plus c. If capital F of x is a function, then d by dx of small f of x, capital F of x equal to, we get small f of x. Then integral of small f of x into dx is equal to, we get the answer capital F of x plus c, where c is called constant of integration. 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 That's all. That's the definition. If capital F of x is a function, then d by dx of capital F of x is small f of x, then integral of small f of x into dx equal to capital F of x plus c, where c is called constant of integration. Okay, now we discuss some result. That's are very important. That is similar to differentiation. You by heart this result. Okay, for finding the integral of some different types of functions. Okay. You already know d by dx of x raised to n. You already know derivative of x raised to n is n into x raised to n minus 1. First result. Okay. First result, d by dx of x raised to n. Answer is n into x raised to n minus 1. Actually, d by dx of x raised to n, answer is n into x raised to n minus 1. Then integral of n into x raised to n minus 1 into dx, answer is x raised to n plus c. It's not a good result. Then you take a d by dx of x raised to n plus 1 is equal to, we get answer n plus 1 into x raised to n. Then that implies integral of n plus 1 is a constant value, no problem. N plus 1 into x raised to n into dx, we get answer x raised to n plus 1 plus c. Okay, and d by dx of x raised to n plus 1 divided by n plus 1. Here n plus 1 is a constant, is equal to 1 by n plus 1 into x raised to n plus 1 derivative is n plus 1 into x raised to n plus 1 minus 1, that is n. Here n plus 1 cancel, we get answer x raised to n. That implies integral of x raised to n into dx is equal to, we get answer x raised to n plus 1 divided by n plus 1 plus c. That's all. That means integral value of x raised to n, answer is x raised to n plus 1 divided by n plus 1. Because you know derivative x raised to n is n into x raised to n. And that time integral of n into x raised to n minus 1, answer is x raised to n. And if derivative x raised to n plus 1, answer is n plus 1 into x raised to n. At that time integral of n plus 1 into x raised to n, answer is x raised to n plus 1 into plus c. And x raised to n plus 1 by n plus 1, at that time 1 by n plus 1 constant, derivative x raised to n plus 1 is n plus 1 into x raised to n. Here n plus 1 cancel, we get x raised to n. And therefore integral of this x raised to n, answer is x raised to n plus 1 by n plus 1 plus c. Okay, clear? That is our first result. D by dx of x raised to n, answer is n into x raised to n minus 1. And therefore integral of x raised to n, answer is x raised to n plus 1 divided by n plus 1 plus c. So this function is different, it's special. Okay, so we by heart this result, integral of x raised to n, answer is x raised to n plus 1 divided by n plus 1. Then d by dx of x, answer is 1. And therefore integral of 1 into dx, answer is x plus c. Integral of 1 into dx, answer is x plus c. Then d by dx of root x, answer is 1 by 2 root x. And therefore integral of 1 by 2 root x into dx, answer is root x plus c. Then d by dx of e raised to x, answer is e raised to x. Here also integral of e raised to x into dx, answer is e raised to x plus c. D by dx of a raised to x, answer is a raised to x into log a and therefore in here log a is a constant, cross multiplying this to denominator, therefore a raised to x into dx is equal, answer is a raised to x, here log a is a constant, cross multiply on the left side, therefore a raised to x divided by log a plus c. Integral of a raised to x, answer is a raised to x by log a plus c. Derivative time we get a raised to x into log a. Then d by dx of log x, answer is 1 by x, and integral of 1 by x into dx, answer is log mod x plus c. Integral of 1 by x into dx, answer is log mod x plus c, because you know derivative of log x, answer is 1 by x, and derivative of log minus x, answer is 1 by minus x into, using function of function, derivative minus x is minus 1 is equal to, we get answer 1 by x. From these two cases, so we get log x and log minus combined to form, we take log mod x, that is integral of 1 by x into dx, answer is log mod x. These two are some different function. First is x integral of x raised to n is x raised to n plus 1 by n plus 1, and integral of 1 by x is log mod x plus c. Okay, by heart these formulas is a very important. Okay, next is 7. d by dx of sin x, you know derivative sin x is cos x, therefore integral of cos x into dx is equal to sin x plus c. Then d by dx of cos x, that is equal to minus sin x, and integral of sin x into dx, answer is this minus 2 transferred to this function, that is minus cos x plus c. Integral of sin x into dx, answer is minus cos x plus c. Then d by dx of tan x, answer is sec square x, and therefore integral of secant square x into dx, answer is tan x plus c. Then d by dx of cot x, answer is minus cosec square x, and therefore integral of cosecant square x, cosecant square x into dx, answer is minus cot x plus c. Then d by dx of sec x is equal to sec x into tan x, and therefore integral of sec x into tan x into dx, answer is sec x plus c. Then d by dx of cosec x is equal to, answer is minus cosec x into cot x, and therefore integral of cosec x into cot x into dx is equal to, this minus change to the left side, that is minus cosec x plus c. These are also very important result. By heart these formulas. On the right side is very important. Integral of cos x sin x, integral of sin x minus cos x, integral of sec square x tan x, integral of cosec square x minus cot x, integral of sec x into tan x sec x, integral of cosec into cot x minus cosec x plus c. These formulas are very important for doing some problems based on this topic. Okay, next. Derivative of sin inverse x, inverse trigonometric function derivative, already know 1 by root of 1 minus s square, and derivative of cos inverse x, answer is minus 1 by root of 1 minus s square. In these two cases, integral of 1 by square root of 1 minus s square into dx is equal to, first answer is sin inverse x plus c, or this minus shifted to left side, that is minus cos inverse plus c. Two possibility ഉണ്ട്. അപ്പോൾ 1 by root of 1 minus s square dx answer ഒന്നുകിൽ sin inverse x plus c or minus cos inverse x plus c. Then d by dx of tan inverse x, answer is 1 divided by 1 plus s square, and d by dx of cot inverse x, answer is minus 1 by 1 plus x square. In these two cases, integral of 1 divided by 1 plus s square into dx, answer is, first is tan inverse x plus c or minus cot inverse x plus c. And last, d by dx of sec inverse x. d by dx of sec inverse x. Answer is 1 by x into root of x square minus 1, and d by dx of cosec inverse x, answer is minus 1 by x into root of x square minus 1. In these two cases, integral of 1 by x into root of x square minus 1 into dx is equal to, we get answer sec inverse x plus c or minus cosec inverse x plus c. Sec inverse x plus c or minus cosec inverse x plus c. Okay, these 15 results are very important, and try to understand this result and by heart it, because we do some problems based on this topic. These results are very important. Okay. Okay. Now we give one more note. If suppose f and g are two functions, then integral of f of x plus or minus g of x into dx is equal to integral of f of x into dx plus or minus integral of g of x into dx. That means two functions add ചെയ്തോ minus ചെയ്തോ വന്നു കഴിഞ്ഞാൽ each time separate നമുക്ക് എന്ത് ചെയ്യാം, integrate ചെയ്ത് add ചെയ്യോ minus ചെയ്യാം. That is the first result. And second is integral of k into f of x into dx. So, a scalar quantity or function of integral, that is k into f of x into dx equal to, answer is k into integral of f of x into dx. K into integral of f of x into dx. These are all two important notes. That is integral of f of x plus or minus g of x into dx. You get answer integral of f of x into dx plus or minus integral of g of x into dx. Second is integral of k into f of x into dx equal to k into integral of f of x into dx. Okay. So, by heart these formulas and do some problems based on this topic will be discussed next class. Before we start, we have one question. Suppose you find integral of x raised to 12. Okay, you already know integral of x raised to n, answer is x raised to n plus 1 by n plus 1. Then x raised to 12, answer is x raised to 12 plus 1 divided by 12 plus 1 plus c. Answer becomes x raised to 13 divided by 13 plus c. Okay, it's very simple portion. Now the second, integral of 5x cube into dx. Here 5 is a scalar quantity. So, it's a constant sit in the left side of the integral value, then x cube into dx outside of the function, that is a 5 into, the integral of x cube is x raised to 3 plus 1, 4 divided by 4 plus c. Okay. Then integral of x square plus x plus 1 into dx is equal to x square into dx plus integral of x into dx plus integral of 1 into dx is equal to, the integral value of x square is x raised to 2 plus 1, that is 3 divided by 3, plus integral of x raised to 1 plus 1, that is x square divided by 2. Integral value of 1 is x plus c, because already you learned the formula integral of 1 is d. Otherwise, you take x1 as x raised to 0. X raised to 0 plus 1 by 0 plus 1, that is x raised to 1 divided by 1, that is x. Integral of x square x cube by 3, integral of x square by 2, integral of 1 x plus c. That's all. Okay. That's all. On next class, we will discuss problems based on this topic. First of all, you by heart these formulas, that is very important. On next class, we will discuss problems using these formulas. Okay, that's all. Bye.